Thinking back to the last video, we looked at the graph of a quadratic function, and we tried to determine where the graph of that function intersected the x-axis. And one of the things that we were wondering was, how can we determine the coordinates of the x-intercepts of a quadratic function without having to rely on the graph? And what we found is that there appears to be a connection between the factors of a quadratic function and the x-intercepts of the graph of that quadratic function. So what we want to do right now is explore how to get from standard form of a quadratic function into factored form of a quadratic function. So let's take a look here at what we're really good at. Okay, what we're really good at right now is taking two linear binomial factors like 2x minus 1 times the quantity x plus 3, multiplying those together using the distributive property or FOIL, and getting a quadratic trinomial that's in standard form. So getting something like 2x squared plus 5x minus 3. What we don't know how to do yet is to start off with the quadratic trinomial in standard form, 2x squared plus 5x minus 3, and break that down into a product of linear binomial factors. Basically the opposite of what we're already pretty good at it. This process of going from a quadratic trinomial in standard form into a product of two linear binomial factors is called factoring. Now, there are a variety of different techniques out there that will allow you to do this process, to go from a quadratic trinomial in standard form into a product of two linear binomial factors. The one that I'm going to try and help you develop today is called either the Xbox method or the area model method. Okay, like I said, this one tends to work well for me. So that's why we're going to actually go through and do it. And it seems to work in most cases. Or work well in most cases. So to do this, what we're going to do is look at, or to develop this idea, what we're going to do is we're going to look at two kind of general linear binomials, x plus a and x plus b, and we're going to multiply them together using an area diagram like we've done in class before. So what I'm going to do is draw a rectangle, and we're going to attempt to find the area of this rectangle if its dimensions are x plus a and x plus b. So I'm going to jot that down. X plus a and x plus b. So those represent the dimensions of our rectangle. Now, to find the area of a rectangle, we can just simply multiply the length times the width, or what we can do is we can break the rectangle down into smaller pieces, find the areas of each of those pieces, and add them together. That's the approach we're going to take here. So I'm going to break this rectangle down into smaller regions, and then we're going to find the area of each region and add those areas together when we're done. So let's just go and take a look at the dimensions of each of the regions so we know, how to find those areas. So this first region, the top left-hand region, which I'm going to highlight in yellow, has dimensions x by x. So to find that area, we're just going to multiply x times x, and that's going to give us, of course, x squared. So it looks like we get a quadratic term up in the top left-hand corner. The next region that we're going to look at is this one that I'm going to highlight in green. Okay, and that region has dimensions x by b. So to find the area of that region, we're going to multiply x times b, and that's going to give us bx. The next region we'll look at is this bottom left-hand region. Now this region has dimensions a, which we can see, by x. So we'll multiply those together and we'll get a times x for the area of that region. And then there's one region left to find the area of, and that's this bottom right-hand region. And that has dimensions a by b. So the total area of that region is going to be a times b. So to find the area of the entire rectangle, now what we need to do is to add up the areas of all of the regions. So the top left-hand region is x squared. The top right-hand region is bx. The bottom left-hand region has area of ax. And the bottom right-hand region has area a times b. Now remember, to find the area of a rectangle, which x squared plus bx plus ax plus ab represents here, we need to multiply the length times the width. Well, in this case, the length is x plus a, and the width is x plus b. So this statement must be true because we're multiplying the length times the width to get the area of the region. So I'm going to simplify the left-hand side a little bit. And I'm just looking at the two middle terms here, and they both contain a factor of x. So I'm going to factor that out. And that's going to leave me with that. And I just changed the order. I just wrote it as a plus b instead of b plus a. Now, here's what we should be noticing. Okay, the first thing is that this middle term, that's what we need to focus on first. That middle term, let's do the highlighter, sorry about that. That middle term, okay, let me get rid of this piece. Is made up of factors of the constant term and the quadratic term. All right, you see here you've got an a and a b and an x. So if we take a times b, the constant term, and multiply it times x squared, what we're looking for are factors of abx squared that give us this middle term. And those factors are, let me slide this down a little bit, ax and bx. So if I multiply ax times bx, I get abx squared. If I add ax plus bx, I get this middle term. And this is the key to being able to factor a quadratic trinomial using the area model. Now you might be a little bit confused right now, which I understand, but what we're going to do in the next video is we're going to look at some examples on how to apply this technique. But when you look back at this video after you've seen some examples, this will help you understand why the method that we're about to learn actually works the way that it does. So you're going to trust me on this one, and we'll see you in the next video.